Today let's descend the sorting algorithm iceberg. Let's go. The bubble sort repeatedly steps through a list, swapping adjacent elements if they're in the wrong order until the whole thing is sorted. It's easy to implement but painfully slow with large lists. Insertion sort. Imagine someone is organizing playing cards by picking one up at a time and inserting it into its correct place in a sorted part of the deck. It's efficient for small or nearly sorted lists, but it gets bogged down with larger random ones. Heap sort builds a binary heap from an array, then extracts the largest element and swaps it to the end, shrinking the heap until the list is sorted. It's like organizing a huge stack of books by always taking the biggest one off the top first. Merge sort splits the array in half recursively, sorts the halves, and then merges them back together in a sorted order. It's like cutting a giant pizza into slices, perfectly arranging each slice and then putting it back into a whole pie. Quicksort is the Bruce Lee of sorting algorithms. It divides and conquers. It picks a pivot element, then partitions the array into two groups, those smaller than the pivot and those larger. It repeats this recursively until the array is sorted. When done right, it's lightning fast, but if you pick a bad pivot, you might regret it. In place merge sort. It's like the merge sort's eco-friendly cousin. It splits and merges but uses only a small constant amount of extra memory, making it more efficient in terms of space. Tree sort takes your lists and puts each element into a binary search tree. Once it's in there, you just walk through the tree and pick the elements in order. It's efficient if you already know how to plant binary trees, but a bit more work than your average algorithm. Gnome sort is like the forgetful gardener who keeps walking back and forth fixing mistakes. It goes through the list, and if two elements are out of order, it swaps them and goes back a step, like a gnome fixing misplaced flowers. It's slow but stubbornly simple. Pigeonhole sort only works if the list elements fit within a specific range, like sorting people by height when you know everyone's between 5 and 7 feet tall. It creates pigeonholes or buckets for each value, then puts the elements in their correct holes. Not very versatile, but extremely fast when it works. Flash sort tries to be clever by guessing where elements belong based on their value. It does an initial distribution of elements into different buckets and then sorts each bucket. It's lightning fast when it works, but it can backfire if the distribution is off. Most significant digit radix sort organizes numbers starting with the most significant part, kind of like starting your homework with the hardest problem first. It's great for certain types of data, like long numbers or strings. LSD radix sort starts with the least significant digits, kind of like sorting the easy stuff first. It handles big data sets by breaking numbers down into smaller pieces, processing each one digit by digit. BOGO sort is the joker of the algorithm world. It randomly shuffles the array and checks if it's sorted. If not, it shuffles it again. It's the sorting equivalent to throwing your papers into the air and hoping they land in the right order. Spoiler, they won't. Slow sort is a parody of an efficient algorithm. It combines recursion and the basic logic of sorting in such a way that it intentionally takes forever. Intelligent design sort posits that the array couldn't possibly be random. Clearly, some higher being must have already sorted it for us. Who are we to question that kind of logic? Dictator sort doesn't care what you think. It declares the array sorted. The array is sorted because the dictator says so. Stalin sort removes any element that disagrees with the sorting order. If a number is out of place, it's gone. By the end, you've got a sorted array. There may be fewer numbers than when you started, just don't ask questions. Quantum BOGO sort runs like BOGO sort, except it sorts in all possible parallel universes at the same time. One of them is bound to be sorted. Miracle sort. Miracle sort doesn't even pretend to try, it sits back and it waits for the array to magically sort itself. And there you go, the sorting algorithm iceberg.